Now see a Coulomb's law. So we have to study here actually the force acting between two charges. Suppose you have taken first charge q1 here, another charge q2, both are here positively charged. These two are the point charges, distance between their center is r. So this will apply force on this, that is a repulsive force acting to this side, that is F21, force on 2 due to 1, and here also the force is acting here F12, force on 1 due to 2, that is also a repulsive force. If you are taking a negative charge q1 and here you have taken negative charge q2, both are again separated by the same distance r, here again is repulsive force F21 and there is F12. Suppose if you have taken here one negative charge q1 and one here positive charge q2, both are the point charge separated by the distance r. Here the force is acting here F21, but this is negative, this is positive, so this is being attracted to this side, so F21 to this side and F12 to this side. So when these two charges are like charges, these like charges, then there is a repulsion. So we can say in these two cases here, we can write q1 q2 is greater than 0. If you multiply these two, you will be getting q1 into q2 greater than 0. And here in this case, q1 into q2 is less than 0. So in this case, force of repulsion, and in this case, force of attraction. So the magnitude of these two forces, these are the mutual forces. So the magnitude of these two forces like F21 is equal to F12 is equal to F. So the magnitude of these two forces are directly proportional to product of the magnitude of the charges and inversely proportional to the distance between square of the distance between these two charges. So according to Coulomb's law, the force acting between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them, and this force acts along the line joining the centers of the two charges. So now we have written F is proportional to product of the magnitude of the charges and proportional to 1 upon r square. We can combine these two, we can write here F is proportional to q1 q2 divided by r square, or we can write F is equal to k. K is proportionality constant here, q1 q2 upon r square. Value of k is here, that is 1 upon 4 pi epsilon naught 9 into 10 raised to power 9 Newton meter square per Coulomb square. Now here this epsilon naught is called absolute permittivity, of free space. Value of epsilon naught is 8.85 into 10 raised to power minus 12 Coulomb square per Newton meter square. So this is the electrostatic force acting between the 2 point charges. This force can be attractive as well as repulsive depending on the sign of the charges. So this is actually a scalar form of the Coulomb's law. Now say Coulomb's law in vector form. Suppose there are two charges q1 and q2 over here. There is a origin, suppose in xy plane, here we have taken. Its position vector is r2 and its position vector is r1. Now if you are taking force on 2 due to 1, it is here F21 to this side, and force on 1 due to 2 is here F12 to this side. Now we can write here, if you want to get F21, so we can take here, this is the vector to this side. So we can write here, this is suppose r vector here. So we can take according to triangle law of vector addition, R1 plus R is equal to R2. So, we can write vector R is equal to R2 minus R1. We can also write here this is vector R is equal to R21. R2 minus R1 we write R21. It means its direction is actually from Q1 to Q2. R21 means direction is from Q1 to Q2. So, we can write here F21 vector is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square into here R21 unit vector. So, see here R21 direction is from Q1 to Q2. Similarly, we can write F12 here. F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and here we can write R12 unit vector. R12 unit vector means here direction is from Q2 to Q1, from this to this side. So, now see here there is R12 and there is here R21, but we know it here R21 is equal to minus R12, direct magnitude is equal but directions are opposite to each other. Therefore, we can write here F21 is equal to minus F12. So, these two forces are equal and opposite to each other. It means Newton's third law is valid here. So, this is the vector form of Coulomb's law of Coulomb's law. So, now see forces between multiple charges. If you have got more than 2 charges, then we have to calculate total force on any one of the charge. Suppose you have taken here this is Q1, here is Q2 and here is Q3. There are the 3 charges. Suppose this is the here origin O here, its position vector from here is R3, its position vector from here is R1 and its position vector from here is R2. Now, suppose if you want to calculate force on Q1 due to Q2, so the force that direction will be here, that is F12. We can write here F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R12 square R12 unit vector. R12 means direction is Q2 to Q2, from Q2 to Q1. Similarly, we can take force on 1 due to 3 and it will be this side here, that is F13. So, we can write here F13 is equal to 1 upon 4 pi epsilon naught Q1 Q3 divided by R13 square R13 unit vector. Direction is from Q3 to Q1. So, the total force on Q1 is given by F is equal to F12 plus F13. So, total force on any one of the charge is equal to the vector sum of the forces acting on the charge due to the presence of the other charges taken individually. And see here, when the forces we are calculating, the forces are not affected by the presence of the another charges. So, this is also known as principle of superposition.